The reconnaissance photograph that reached German intelligence headquarters in Berlin on June 10, 1944, showed something that seemed to violate the basic laws of wartime resource management. Massive American fuel depots stretching across the English countryside, each containing what appeared to be unlimited quantities of aviation gasoline, diesel fuel, and motor oil stored in perfect geometric patterns of steel drums and underground tanks. Oberst Wilhelm Richter, chief of Wehrmacht fuel logistics, studied the images through his magnifying glass and shook his head in disbelief. Each of these depots contains enough fuel to supply our entire army group for 6 months, he muttered to his staff officers. The Americans appear to have more fuel in reserve than we consume in a year of combat operations. These were experienced German logisticians who understood that fuel scarcity was the fundamental constraint limiting military operations in modern warfare. They had calculated Allied petroleum requirements, analyzed shipping capabilities, and developed mathematical models proving that sustained offensive operations across multiple theaters would exhaust enemy fuel reserves faster than any conceivable supply system could maintain adequate stockpiles. They had no way of knowing they were witnessing the greatest petroleum mobilization in military history, or that American fuel abundance would soon enable Allied operations of such scale and intensity that German forces would be overwhelmed not by superior tactics, but by unlimited mobility that rendered traditional defensive strategies completely obsolete. General Major Georg Thomas, chief of Wehrmacht economic planning, stood before his logistics staff in Berlin during March 1943, confident that German fuel conservation measures and strategic petroleum allocation would enable victory through efficient resource utilization that Allied forces could never match. As architect of German wartime economics, Thomas embodied Nazi assumptions about resource scarcity that would soon be shattered by American abundance beyond any European calculation. The German fuel shortage that dominated Wehrmacht strategic planning reflected genuine constraints that had shaped military operations since the war's beginning. German synthetic fuel production, Romanian oil imports, and captured Soviet petroleum facilities provided barely adequate supplies for existing military requirements, creating mathematical certainty that prolonged warfare would favor forces with superior resource conservation and tactical efficiency. Intelligence analysis of Allied fuel capabilities suggested American petroleum reserves remained limited by tanker shipping losses, refinery capacity constraints, and civilian consumption requirements that prevented massive military fuel accumulation. German U-boat campaigns had sunk thousands of Allied tankers, creating reasonable expectations that enemy fuel shortages would limit operational scope and strategic mobility. The strategic doctrine that guided German military planning assumed fuel scarcity would remain the decisive constraint limiting offensive operations and strategic mobility. Wehrmacht commanders developed tactical approaches that minimized fuel consumption while maximizing combat effectiveness through concentrated attacks, defensive positioning, and operational economy that conserved petroleum resources for critical engagements. Economic calculations performed by German planners revealed American fuel production allocated between civilian automotive needs, industrial requirements, and military consumption that indicated insufficient surplus capacity for massive overseas military operations. Gasoline rationing programs and speed limit restrictions suggested American fuel limitations similar to European resource constraints. Technical analysis of captured American vehicles indicated fuel consumption rates that exceeded German efficiency standards, suggesting enemy forces required greater petroleum supplies to maintain equivalent operational capability. American tanks, aircraft, and transport vehicles appeared less fuel efficient than German equipment designed for resource conservation and operational economy. The psychological foundation of German fuel confidence rested on successful resource management that had enabled military victories through systematic conservation and efficient allocation. German forces had achieved remarkable operational success despite fuel limitations through tactical excellence and strategic innovation that maximized combat effectiveness while minimizing petroleum consumption. Supply chain analysis suggested American fuel distribution systems remained vulnerable to submarine interdiction and strategic bombing that could create critical shortages despite potential production advantages. German intelligence indicated Allied petroleum infrastructure concentrated in vulnerable coastal refineries and transportation networks susceptible to military disruption. Cultural assumptions about American consumer society suggested excessive fuel consumption habits that prevented effective military allocation and resource discipline. German propaganda portrayed Americans as wasteful consumers who lacked systematic organization necessary for efficient wartime petroleum management and strategic resource allocation. The mathematical models that justified German strategic planning proved Allied forces could not sustain major offensive operations across multiple theaters while maintaining adequate fuel reserves for continued combat effectiveness. Petroleum arithmetic indicated German defensive strategies would eventually exhaust enemy fuel supplies through systematic attrition warfare. International petroleum markets appeared controlled by Axis forces through territorial conquest and diplomatic influence that limited Allied access to global oil supplies. German control over Romanian production and potential influence over Middle Eastern resources suggested strategic advantages in petroleum availability. Military experience during 1941 to 1942 seemed to validate German assumptions about fuel constraints limiting Allied operational scope and strategic mobility. Enemy forces had demonstrated tactical competence but appeared constrained by logistical limitations that prevented sustained offensive operations or unlimited tactical flexibility. The fuel famine fallacy was complete, and German strategic planning proceeded under assumptions about resource scarcity that would soon be demolished by American petroleum abundance, exceeding any mathematical possibility that European military tradition had ever contemplated. Harold Ickes, Secretary of the Interior and Petroleum Administrator for War, stood in the control room of the Big Inch pipeline in Texas, watching gauges that monitored oil flow rates exceeding 300,000 barrels daily from southwestern oil fields to East Coast refineries. The infrastructure he oversaw represented American petroleum capabilities that would soon overwhelm German fuel limitations through systematic abundance rather than conservation necessity. The American petroleum industry that supported military fuel requirements possessed production capacity that exceeded total global consumption before the war began. Texas oil fields, California refineries, and Gulf Coast processing facilities operated at expanded capacity while maintaining civilian fuel supplies and building strategic reserves that European planners considered mathematically impossible under wartime conditions. Pipeline construction across continental United States demonstrated logistical capabilities that German intelligence had never contemplated as realistic possibilities. The Big Inch and Little Big Inch pipelines transported petroleum products over thousands of miles through terrain and distances that European fuel distribution had never attempted to cover through systematic infrastructure development. Refinery capacity expansion represented American industrial mobilization applied to petroleum processing that achieved production rates exceeding pre-war global totals. New facilities constructed within months provided aviation gasoline, diesel fuel, and lubricating oil in quantities sufficient for global military operations while maintaining civilian transportation and industrial requirements. The workforce mobilization that supported American petroleum production included technical experts, construction workers, and transportation personnel recruited from civilian industries through systematic training programs that created human resources adequate for continental petroleum operations. Democratic education systems provided technical knowledge necessary for advanced petroleum engineering and systematic resource development. Supply chain coordination across American petroleum industry demonstrated organizational capabilities that exceeded European logistics through systematic integration of production, transportation, and distribution networks. Oil field development, pipeline construction, and refinery operations proceeded simultaneously through collaborative planning that maintained continuous fuel flow despite continental distances. Quality control procedures in American fuel production ensured consistent performance standards across military and civilian applications while maintaining chemical specifications required for advanced aircraft engines and precision mechanical systems. Petroleum products met rigorous requirements through systematic testing and continuous quality assurance that exceeded traditional fuel standards. Innovation acceleration in petroleum technology continued throughout production expansion as American chemical engineers developed improved aviation fuels, synthetic lubricants, and specialized petroleum products that enhanced military equipment performance while maintaining production schedules that traditional methods couldn't achieve through individual craftsmanship or limited technical development. International cooperation through petroleum sharing provided fuel supplies to Allied forces worldwide while maintaining domestic reserves that indicated production capacity far beyond German intelligence estimates. British, Soviet, and other Allied militaries received American petroleum products that enhanced operational capabilities while demonstrating systematic abundance. The economic efficiency that American petroleum production achieved included cost reductions through volume processing and systematic optimization that enabled superior fuel quality at lower unit prices than traditional production methods could accomplish through individual attention or limited processing capacity. Strategic stockpiling, beyond immediate military requirements, demonstrated American confidence in continued petroleum leadership through competitive innovation and systematic resource development. Fuel reserves accumulated at scales that provided insurance against supply disruption while enabling sustained operations regardless of tactical losses or strategic setbacks. The environmental management that accompanied petroleum expansion included conservation measures and systematic resource utilization that maintained production sustainability while meeting immediate military requirements. American petroleum democracy balanced resource development with environmental responsibility through competitive regulation and systematic planning. Transportation networks supporting petroleum distribution included tanker fleets, railroad systems, and trucking operations that moved fuel products across global distances while maintaining delivery schedules that European logistics had never attempted through systematic organization. The petroleum democracy was achieving fuel abundance that would soon enable Allied operations of unlimited scope and intensity. July 1944. The Normandy invasion had been supplied with over 1.2 million gallons of fuel daily through underwater pipelines, floating storage facilities, and continuous tanker operations that created petroleum abundance German defenders had never encountered in modern warfare. American logistics personnel established fuel depots faster than German forces could target them, creating strategic mobility advantages that rendered traditional defensive calculations obsolete. The Pluto, Pipeline Under the Ocean, project demonstrated American engineering capabilities applied to fuel logistics that achieved impossible petroleum transportation across the English Channel through underwater pipeline systems. Fuel flowed continuously beneath ocean waters, while German forces remained unaware of infrastructure that enabled unlimited Allied mobility and tactical flexibility. Fuel depot construction across liberated Europe proceeded with systematic organization that established massive petroleum storage facilities within days of territorial capture. American engineering units deployed standardized equipment that created 50,000-gallon storage capacity through prefabricated components and systematic assembly techniques adapted from industrial construction methods. The logistical coordination that supported fuel abundance included transportation networks connecting petroleum sources to combat formations through systematic distribution that maintained adequate supplies regardless of operational tempo or tactical requirements. Fuel trucks, pipeline systems, and storage facilities operated with continuous efficiency that eliminated traditional petroleum constraints from military planning. Quality assurance procedures ensured fuel performance standards across diverse operational requirements while maintaining chemical specifications necessary for aircraft engines, tank power plants, and transport vehicles. American petroleum products met rigorous military standards through systematic testing and continuous quality control that exceeded traditional fuel reliability. The strategic reserves that American forces maintained at every operational level included fuel stockpiles sufficient for extended combat operations without resupply dependency. Division-level petroleum storage exceeded German Army Group reserves while maintaining tactical flexibility that enabled rapid operational changes without logistical constraints. Consumption analysis revealed American fuel usage that exceeded German estimates by factors that challenged understanding of petroleum requirements for sustained military operations. Allied forces consumed fuel at rates that indicated unlimited availability while maintaining operational tempo that German forces couldn't match, despite tactical competence and strategic positioning. Supply chain resilience included redundant fuel distribution systems that maintained petroleum flow despite enemy interdiction attempts or tactical disruption. American logistics networks provided alternative transportation routes, backup storage facilities, and emergency supply procedures that ensured continuous fuel availability under combat conditions. The psychological impact on German forces included recognition that Allied petroleum abundance eliminated traditional advantages of defensive positioning and tactical conservation. German commanders discovered that fuel-efficient tactics couldn't offset enemy capabilities for unlimited mobility and sustained offensive operations through petroleum superiority. Innovation integration in fuel logistics included specialized petroleum equipment, mobile refueling systems, and advanced storage technology that enhanced distribution efficiency while maintaining safety standards required for combat operations. American engineering continuously improved fuel handling through competitive development and systematic optimization. International fuel sharing provided petroleum products to allied nations while maintaining American operational requirements at levels that exceeded domestic consumption despite global military commitments. Fuel abundance enabled coalition warfare through generous allocation that strengthened partnership effectiveness. The maintenance infrastructure supporting fuel operations included repair facilities, replacement equipment, and technical personnel that sustained petroleum systems under combat conditions. American logistics provided systematic support that maintained fuel availability regardless of equipment failure or operational damage. Economic calculations revealed fuel costs decreasing as consumption volumes increased, demonstrating economies of scale that traditional petroleum operations had never achieved through systematic optimization. American abundance created cost advantages through volume efficiency and competitive procurement. The fuel flood was drowning German defensive strategies through American petroleum capabilities that exceeded mathematical possibilities of resource constraint, enabling Allied operations of unlimited scope and intensity. September 1944. German intelligence analysis revealed American fuel consumption that defied mathematical possibility. Allied forces were burning over 10 million gallons of petroleum products daily across European operations, while maintaining strategic reserves that appeared to increase rather than diminish despite massive operational tempo and continuous combat requirements. Oberst Wilhelm Richter stared at logistics reports documenting American fuel capabilities that violated every assumption about petroleum limitations and resource constraints that had shaped German strategic planning. Allied forces possessed fuel abundance that enabled tactical flexibility German commanders had never encountered in modern warfare, creating operational possibilities that traditional military planning had never contemplated. The mathematical calculations that German logistics experts performed revealed American petroleum consumption exceeding total German fuel production by ratios that challenged understanding of industrial capacity and resource allocation. Allied forces used fuel quantities that indicated unlimited availability while maintaining civilian supplies and supporting global military operations simultaneously. Statistical analysis of captured American fuel storage facilities documented petroleum reserves at individual depots that exceeded German Army Group allocations for entire campaigns. Single Allied fuel dumps contained sufficient petroleum for sustained offensive operations that German forces couldn't maintain, despite tactical advantages and defensive positioning. Supply chain documentation revealed American fuel distribution networks operating with systematic efficiency that maintained petroleum flow across continental distances while supporting simultaneous operations in multiple theaters. Fuel logistics achieved coordination that exceeded German organizational capabilities despite superior military tradition and systematic planning. The economic implications of American fuel abundance included cost advantages that decreased as consumption increased, contradicting German assumptions about resource constraints and strategic limitations. Allied forces achieved petroleum efficiency through volume procurement and systematic distribution that traditional supply methods couldn't match through conservation measures or tactical economy. Quality control analysis indicated American fuel standards that exceeded German requirements while being produced in quantities that German chemical industry couldn't approach through any conceivable resource allocation or industrial conversion. Mass production had achieved petroleum quality through systematic methods that individual processing had accomplished only through specialized attention. Strategic planning revisions necessitated by intelligence reports required acknowledgement that German fuel limitations created tactical disadvantages that superior training couldn't overcome against enemies with unlimited petroleum availability. Traditional defensive strategies based on resource attrition became obsolete against forces with inexhaustible fuel supplies. The psychological transformation of German commanders included recognition that tactical excellence couldn't offset material disadvantages of such magnitude. Fuel abundance enabled Allied operational flexibility that exceeded German response capabilities despite superior tactical knowledge and defensive preparation. International cooperation through fuel sharing had provided American petroleum to Allied nations while maintaining domestic reserves that indicated production capacity beyond German intelligence estimates. Fuel abundance enabled coalition warfare through systematic generosity rather than competitive resource allocation. Innovation acceleration in petroleum technology had demonstrated American ability to improve fuel quality while maintaining production schedules that traditional methods couldn't achieve through individual processing or specialized manufacturing. Competitive development encouraged continuous advancement that exceeded German chemical engineering despite theoretical knowledge advantages. The workforce development that enabled American success challenged German assumptions about petroleum industry requirements and social organization. Civilian workers had contributed to fuel production through systematic inclusion that enhanced rather than compromised operational effectiveness, contradicting authoritarian beliefs about technical expertise and hierarchical control. Logistical comparison between American and German fuel capabilities revealed disparities that explained Allied operational success across multiple theaters. American forces possessed petroleum advantages that eliminated supply constraints, while German operations remained limited by fuel shortages that reduced tactical effectiveness. The arithmetic of abundance had rendered German fuel conservation strategies mathematically irrelevant against American petroleum capabilities that exceeded any conceivable tactical response through industrial abundance rather than strategic innovation. May 8, 1945. As Nazi Germany surrendered unconditionally, the final accounting of American petroleum mobilization revealed numbers that had redefined military logistics. Over 7 billion gallons of fuel had been distributed to Allied forces worldwide, creating mobility advantages that had enabled victory through systematic abundance rather than tactical superiority or strategic innovation. General Dwight D. Eisenhower stood beside a fuel depot in Germany that contained more petroleum than the Wehrmacht had possessed during entire campaigns, representing American logistical capabilities that had overwhelmed enemy resistance through unlimited mobility, rather than requiring tactical brilliance or strategic complexity to achieve decisive victory across global theaters of operation. The human achievement of American petroleum democracy became apparent through systematic analysis that revealed fuel abundance had been accomplished through voluntary cooperation and competitive innovation, rather than requiring brutal sacrifice or authoritarian control. American petroleum workers had earned higher wages and worked better conditions while producing fuel that exceeded Axis capabilities. Technical innovations in petroleum production had revolutionized fuel manufacturing methods that would influence global energy industry for generations through systematic approaches to quality control, distribution networks, and continuous improvement. Democratic competition had encouraged advancement that exceeded traditional methods through scientific management rather than cultural tradition. Economic efficiency of American fuel production had achieved cost advantages through volume processing that enabled superior quality at lower unit prices than traditional petroleum methods could accomplish through individual attention or limited processing capacity. Competitive capitalism had proven more effective than command economy organization for systematic resource allocation. The workforce diversity that enabled American success had demonstrated social advantages of democratic inclusion over hierarchical restrictions that authoritarian ideology had promoted. Women, minorities, and civilian workers had contributed technical skills that enhanced petroleum production effectiveness through systematic participation rather than ideological conformity. Innovation integration throughout fuel production had contradicted authoritarian assumptions about the relationship between quantity emphasis and technological advancement in petroleum engineering. American chemical engineers had achieved continuous improvement while maintaining production schedules through competitive methods that centralized planning had never accomplished. International cooperation through fuel sharing had established American leadership in global energy systems that enhanced collective security through systematic abundance rather than exploitative relationships. Democratic values had created sustainable partnerships that would influence post-war energy development through competitive collaboration. Strategic planning that exceeded immediate military requirements had demonstrated American confidence in continued petroleum leadership through competitive innovation and systematic resource development. Fuel production capacity had enabled rapid conversion to civilian consumption that maintained economic prosperity during peacetime transition. The educational systems that produced American petroleum workers had created human capital advantages through democratic participation and individual opportunity rather than hierarchical control or ideological indoctrination. Technical knowledge and innovative thinking had emerged from competitive education rather than authoritarian instruction. Quality control achievements through mass fuel production had established petroleum standards that exceeded traditional processing, while enabling systematic output that would dominate global energy markets through scientific methods rather than cultural heritage or limited technical knowledge. The logistical networks that supported fuel abundance had created transportation and distribution systems that maintained global petroleum flow through systematic organization and competitive efficiency that exceeded any previous energy infrastructure through democratic planning rather than authoritarian control. The fuel that powered Allied victory had carried more than military mobility. It had demonstrated systematic advantages of democratic society that would reshape global energy relationships through industrial capability, technological innovation, and competitive abundance that authoritarian systems could never match through coercive control or ideological superiority. If this incredible story of how American petroleum abundance overwhelmed German fuel limitations through democratic energy supremacy amazed you, make sure to subscribe to our channel for more untold tales of logistical victories that changed world history.